Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss the measurement of pressure. In the previous lecture, we have seen the definition of pressure and the types of pressure. So in this lecture, we'll discuss how to measure the pressure in different ways. So measurement of pressure actually categorized into two types. One is it can be measured with the help of manometer, and another one procedure is there with the help of mechanical gauge. Okay. And manometer actually it is categorized again, two types are there. Two types of manometers it is categorized. One is simple manometer is there. Another one is differential manometer is there. Okay. And this mechanical gauge again categorized into four types. Four categories are there. First one is, you can say, the diaphragm pressure gauge. Okay, this diaphragm pressure gauge is nothing but, you can see, this is the example of, or this is the picture of this diaphragm pressure gauge. Actually, this is basically used for the low pressure. This is basically used for the low pressure. And second one is Bourdon type pressure gauge. Bourdon tube pressure gauge is there. And this is the picture of this Bourdon tube pressure gauge. And mostly it is used for low pressure as well as high pressure. Okay. And third one is deadweight pressure gauge is there. Deadweight pressure gauge. Okay, deadweight pressure gauge is nothing but, you can see, this is the deadweight pressure gauge. And the last one is bellows pressure gauge. Bellows pressure gauge also similar kind of to diaphragm pressure gauge, which is also used for the low pressure. Okay, though all these pressure gauges are included or it is applied for measuring the liquids. It may be any kind of liquid, maybe air, or it can take water, or you can consider any oil industry, petroleum industry is there. So application of these different pressure gauges are applied in different places based on the requirement. And but basically this Bourdon pressure gauge, Bourdon tube pressure gauge used to use most of the places. That is referred more, as it can be used for the low pressure and as well as the high pressure also. That's why it is more in demand. This is all about the pressure mechanical gauge. And now coming to the manometer, this manometer is categorized into simple and differential. So simple is, again, the simple manometer is categorized into three types of it. So first one is piezometer. And second one is U-tube manometer. And third one is single column manometer. So these are the three types of manometers in the simple. Again, differential also different types are there, that we'll discuss later. So while coming to the simple manometer, first one is piezometer. So let me give you some information regarding the piezometer. So piezometer actually is very simple kind of manometer is there. Okay, so the construction of this piezometer is very simple. So let one pipe is there. Okay, and here the pipe is there, and the pipe, inside that liquid is flowing, and when the liquid is flowing, you want to measure the pressure of this liquid, then you can insert a piezometer inside this, and the piezometer construction is like this. Okay, one end of this piezometer, okay, one end of this piezometer will be open to the atmosphere. So that is pressure at atmospheric, and this is the pipe. Okay, this is the pipe where the suppose water is flowing. Okay, we can consider this is the pipe is there, and where any kind of liquid is flowing, if you want to measure the pressure of this liquid, you can insert a tube inside that, and the tube is looks like this. One of the end will be connected to this center point of this tube. Okay, and another end will be open to the atmosphere. So for this piezometer, if you want to calculate the pressure of this liquid which is flowing here, that can be calculated. P equal to rho g h. P equal to rho g h. When you insert this tube inside this one, you can see there is a rise in liquid in this tube, and how much rise in this liquid, so that is, you can mark as h. You can indicate that one as a h. That means how much height increase in this tube after inserting this one. So you can say the pressure of this liquid in this which is flowing inside the pipe is P equal to rho g h. Rho here density, h is the height which is increased in this tube, and we can calculate the pressure at A point. You can give, already I have given a point here, so pressure at A point equal to rho g h. This is the piezometer. Similarly, the second one is U-tube manometer. Okay, second one is U-tube manometer. The name itself gives the description about the manometer. The shape of this manometer will be U-type will be there. Okay, and this kind of tube, we know that it is made of, glass tube will be there, and in the glass tube marking will be there. The scaling will be there of this tube, so that you can easily understand or easily identify the value of height, how much increment is there in this. Now U-tube manometer also similar kind of thing is there. So one end will be open to the atmosphere, another end will be connected to this pipe, and this U-tube manometer again, this can be applied for both conditions, like for gas pressure and for vacuum pressure. So for the gas pressure and for vacuum pressure, two different diagram will be there. So one diagram first let me draw here. Suppose this is the pipe is there, and here inside this. Okay, now as I told you, this is a U shape is there, and so the U shape can be drawn like this. Okay, and suppose this is the pipe is there, and in this pipe, let's say here the liquid which is flowing, let's consider it is water. Simple thing, let's consider the water is flowing inside the pipe, and we need to find out the pressure at this point. Let's give this point A. Okay, and in this manometer, actually there is some liquid is there, some different color. Let's check it. Yeah, here already we have some liquid in this manometer. Okay, that is nothing but mercury we to consider. Okay, so in this case, actually what we need to consider, why mercury is considered here. Now the mercury is having high density than the liquid which is flowing inside the pipe. We need to consider such kind of liquid in this manometer whose specific gravity or density will be more than the liquid which is flowing inside the pipe. Okay, so that's why here the liquid which you have taken the U-tube, that is mercury is there. Okay, and this is for gas pressure. This diagram is for gas pressure. Let me tell. Okay, so at initial condition, what will happen? This mercury which is present here, okay, and the liquid which is present in this pipe, let it is in normal condition before flowing, and here one, you can keep one valve which will be easy to operate here, and suppose when the flow will be there inside the pipe, you can open this pipe. Okay, if you want to measure the pressure of this pipe flow in this point, so what we'll do, let's open this valve. So when you open this valve, you can see this liquid started flowing here. Which one? This liquid will start flowing inside this, and it will be given a pressure on this mercury. So it will be keep an impact pressure on this mercury, and this is which is open to the atmosphere. That is, we know that P atmospheric pressure at the atmospheric region. Okay, and P gas pressure, we know that gas pressure is always more than the atmospheric pressure. So the pressure which is present in this pipe, that is gas pressure. That is gas pressure. So when it will be given impact on this one, then we can see there is a rise in this mercury, okay, towards this. Okay, so let give a reference line here. Let give a reference line here, and that line we can say is an XX line, or that is called a datum line. It is called a datum line. Okay, and this datum line, actually from this we can estimate the pressure of this point. So how to estimate the pressure of this? Now, after flowing the liquid inside the pipe, so what is the height was here? What is the height of this liquid which is giving an impact on this mercury? So this liquid, actually you can give H1. This liquid distance from the center point to this datum line, let's give H1. And due to this impact, what is the rise in mercury up to this level? And this one we can give a height of H2. This one we can give a height of H2. Okay, and see this raised in mercury level. Why? Because of due to this impact of this pressure of this liquid after flowing. Okay, so that from here how much rise in height is there, that we can take H2. So H2, and this is H1. This is for the gas pressure. Okay, now for gas pressure we can we have drawn this diagram. Now similarly for the vacuum pressure will be there. Let consider the vacuum pressure. So vacuum pressure, what kind of diagram can be drawn? So let me draw one diagram here. Similar kind of okay, and as I told you, this is a U-tube manometer. So the shape of this manometer will be U shape will be there, and this is the pipe is there. Okay, and let's take this is the same point, A point or B point. We can give a point here, and here again similar thing will be there, but the name itself you can say vacuum pressure. And we know that we already previously discussed the vacuum pressure will be always less than the atmospheric pressure. And here, as I told you, this end is open to the atmosphere. So obviously when atmospheric pressure will be giving impact on this, and the pressure which is in this, you can say this is in this pipe we have vacuum pressure. Okay, in this you have vacuum pressure, and if we want to measure the pressure in this vacuum, then obviously we can keep a manometer to this, and this will be give a impact. And see, now here the atmospheric pressure will be give impact on this, and let here also consider a datum line. Okay, and here also let consider datum line, and the liquid which will be there, again we can consider the same heavy liquid or mercury here. You can consider here mercury. So this zone will be filled, okay, with mercury. And the next thing is, we can say this atmospheric pressure will be give a impact on this mercury, so that there is a high liquid rise in this side also, that can be considered as a H1. Okay, so there is a liquid height will be there, and this will be the you can say the liquid which is present here, that is the height of say H2, and this is you can say H1. Okay, now let identify what is the pressure at this point of B and what is the pressure at this point A. And before that, here we need to clarify that this H equal to H1 equal to this H1 equal to height of light liquid, height of light liquid above the datum line, above the datum line. And similarly H2 equal to height of heavy liquid, H2 equal to height of heavy liquid, and which is above the datum line again, okay, which is above the datum line. H2, okay, here it is H1 actually, H1, yes, H2, same only, because this is the heavy liquid which is given here. This is H2 and this is H1. Yeah. Next, H1 equal to H1 H2 we told. Next is we need to consider similarly density rho 1 and this is density rho 2, density of the light liquid, then specific gravity of the light liquid Sg1 and specific gravity of heavy liquid Sg2, rho 2 equal to density of the heavy liquid at this part. Okay, these are the concept of this. Now for the gauge pressure, we'll find out this pressure value. Let me calculate this next page. Yeah, or here for P gauge you can write. Okay, now see this diagram. So here this is our right limb and this is our left limb. Okay, or we can say this is right side manometer, this is left side manometer. So what is the pressure at this right side and what is the pressure at the left side? So left side, if you see, this is having a pressure at this inside the pipe, so that is PA, suppose this is PA, plus the liquid which is flowing with the height of this H1, so that will have another one pressure will be there, so that is rho G H1 we can say. So at the left side, so pressure at the left side manometer, we can write PA plus rho 1 G H1. Okay. Similarly, in the left side, what will be there? This is the height of increment in the heavy liquid, that is H2. So that one you can write. So P at the right limb, equal to rho 2 G H2. Okay, so here we can write, if you equalize this right side pressure and left side pressure, both will be equilibrium should be there. So you can write PA plus rho G H1 equal to, you can write rho 2 G H2, and PA equal to, you can write rho 2 G H2 minus rho 1 G H1. So this is the pressure at the A point for the gauge pressure condition. Okay. Now similarly for the vacuum pressure condition, so vacuum pressure what will be there? As we have seen here, this is right side here. This is your right limb and this is your left limb. Let's find out this. So the pressure at this B point, we can write for vacuum pressure, we can write this one. P at the left side equal to, what will be there? PB, okay, and or you can write PB, you can write, no issue. And what is there? Rho 1 G H1 plus here rho 2 G H2. Now the value we need to consider always above the datum line. Similarly here also you have seen the value, this height and this height we have taken above the datum line. So similarly here also we need to consider the pressure above the datum line. So one pressure which is present inside the pipe, and second one is the light liquid pressure, and one is the heavy liquid pressure. So what is the pressure at the right side? Right side pressure will be nothing. Here there is no pressure is there because this is the vacuum pressure condition, so which is lower than the atmospheric one. So right side pressure will be 0. So we can write this pressure equal to this one, you can write PV equal to minus of, we can consider rho 2 G H2 minus plus rho 1 G H1, because both things we take to other side, and that will be give you a minus value. Okay, because the vacuum pressure, we know that always it will be give a negative value, so we can identify the pressure value at this pipe. Okay, will be give a negative for the vacuum pressure condition, and for the gauge pressure we'll get a positive value in that case. So I hope you understood how to measure pressure and different type of pressure gauges are there, and about the piezometer and U2 manometer. And in the next lecture we'll discuss about the single column manometer. So I hope you understood. If you are having any doubt regarding this, you can give a comment on the. Thank you all.